Okay, example number 2 for section 6.1. Okay, the problem says the voltage across a 600 microhenry inductor is shown in the figure. Okay, that's this figure. Okay, the voltage as a function of time is shown in the figure. Now, the current at t less than 0 is known to be 0, less than or equals to 0. So the initial current is 0. What we are supposed to find is we are supposed to derive an expression for current in the time interval between 0 less than or equals to t less than or equals to t 2 milliseconds. Okay, so simply this is a different type of problem, very similar, but something that we have not seen before. Let us write out what is given. Given is the expression for inductance. Okay, it's not an expression, it's a representation on a graph. Okay, the inductance value is given to be 600 microhenry, and then the voltage as a function of time is given. Okay, it's given as a graphical function. Now, if you think about it, it's given as for 0, 15 millivolts actually, for 0 less than or equals to t less than or equals to 2 milliseconds. Okay, so an expression as a function of time is given. Now, if you think about it, we can go back to our formulas, right, and see which one applies. What we are really seeing is that we know the voltage, very good, and we know the inductance value, and we are supposed to find the current. So clearly, this formula, I of t is 1 over L, t naught to t, v of t dt. This formula is going to apply. Okay, so let's paste it here. Okay, and I'll go back and clean up this formula a bit. Okay, there you go. So this formula we are going to apply because we know the value of v of t and we know the value of L. Now, simply I of t, therefore, equals to 1 over L, which is 1 over 600 microhenry, multiplied by t naught is 0 and t is 2 milliseconds, okay, multiplied by v of t dt, okay, plus if there is any initial current, I of t minus t naught, okay, I of t minus 0. Okay, any initial current, which is given to be 0. This is given to be 0. Right? So now we simply have to plug in the known values. 600 microhenry, integral 0 to 2 milliseconds. This guy is what? 15 millivolts dt. Okay, dx. We can change the variable 15 into 10 to the negative 3 dx. Okay, 15 milli times dx. Now we can plug that in to the equation. What you will see is that this is going to be 15 10 to the negative 3 by 600, 15 10 to the negative 3 by 600 microhenry. Okay, 600 microhenry times t from 0 to 2 milliseconds. Okay, so we can plug those values in, and then once we plug in the value of 2 milli and 0, the answer is going to be I of t is 25t. Okay, that is what we are after. We are interested in finding the value of I or the expression for I in this 0 to 2 milliseconds range. Okay, 25t. Think about this. Let's go back to the plot. Okay, you have a voltage that is constant. So let's pay careful attention, trying to understand the intuition right here. The voltage in this time range is constant. And then when we look at the expression for current, 25t, you may plot it and you will see that the current is actually something like that. That's current, okay? Where the slope is 25, okay? So this is the current 25t going through origin, okay? This is I of t. Now, what you will notice pretty intuitively is that when the voltage across an inductor is constant, the current is a straight line. Okay, think about it. The integral of a constant is a straight line, and that's what it means. Okay, so the answer here is I of t is 25t.